All right, good morning. We're going to look at simulating additive manufacturing in 3D Experience. The first thing we're going to do is import our part. We'll go up here to this plus sign and hit import. And then we'll find our file. In this case, it's a SolidWorks file. So we'll go ahead and open it. And then we'll click OK. And from here, we're going to go to the Tools tab. We're going to go all the way to the right and go to Browse Materials. We're going to grab titanium as our material and click Apply. Then we'll close this, click the part, click the green check, and now in the window on the left over here, we have materials, we have our TI ALV4, 4V. Now let's go ahead and save this. But first, we'll rename it. So right click on this in the tree and go to Properties. And we'll just say Test. Okay. Now let's save it. Great. So let's open up a new tab. We'll go to the VR quadrant and go to powder bed fabrication. Now we'll create a machine. .300 by 300 by 150. That'll be our dimensions. And 1 and 0, these are key. And 0.1 and 0.5. That's from the tutorial that I saw in 3D Experience's EDU space. So the build tray, will make it slightly smaller, 200 by 200. And then the height, just 50, radius, 35. Now let's go to View and Fit All in the view. So now it's all in the view. Now we'll go to Build Layout. And we're gonna add a rule. We're gonna say that the distance between the part and the build tray is 0 millimeters. And we'll click OK. Now we'll search for a part. And we'll go back to our part tab and click the part name in the top of the tree. Now we're going to go to the orientation button right here, part orientation, and we'll go to manual orientation, and we'll hit the pencil icon to edit the orientation. And then we'll go to 80 degrees. You can click and drag, and then you can use your mouse buttons or your arrow keys to move to 180 degrees rotation. Hit the compute button, apply to all, OK. Now we will add a part instance. It's that button right there, and we'll hit the green check. So that way the flat surface is on the part bed, which is what we want. Now supports, we'll skip that because the part is directly on the bed. We'll go to scan path. Now let's create a rule for this. All the defaults are good. We'll select our part, and then we'll create a rule for this section. And for composite strategy, we're going to add a contouring rule. And for the number of contouring passes, we're going to put 2. And then for hatching, we're going to make the angle of rotation 45 degrees. We'll click the green check. Then we'll hit this button, select/unselect all parts. And we'll click this drop down and click Scan Path Rule 1. And then we'll hit Generate, and then display the path. So if you want to zoom in, you can click the middle mouse button and then the left mouse button, one after another. And then you release the left mouse button, and that gives you the zoom function. So you can zoom in and then take a screenshot if you need it for a report. Now we'll hit the OK button after we exit out of our scan path. And we're going to move on to the additive manufacturing scenario. Click OK. Mechanical, thermal mechanical, that's what we want to use. And we'll go to Setup, Finite Element. And the mesh size, we'll just do 10, 10, 10 for the initial setup. Click OK. And we'll go to the material palette. Actually, we already have the material selected for the part, so we can pick a material and pick our part and then click our bed and click the green check. So now we have two materials, one for the part and one for the bed. Now we'll go to our parts and support / properties, and we'll go to the connections tab, and then we'll go to tie detection. And from here, we're going to make our tolerance 1/1000th of a millimeter. We'll click the tie rotation degrees of freedom and adjust slave initial position. Then we'll hit find ties, and we'll double click on the tie that pops up. Click the OK button, and then hit OK. So now we're moving on to starting temperature. Click the starting temperature, and we'll make the melting temperature 1941. And click OK. Now moving heat flux. The absorption value will make 0.5. Click the OK button. Material deposition. We'll hit the defaults for that. Cooling. We will make the convective coefficient 18 and the emissivity 0.5. The OK button. Now we'll go to structural restraints and loading, hit the clamp button, and then to rotate your part, click the middle mouse button and hold your left mouse button. And then you can rotate your part, and you can click the bottom surface and then hit OK. Again, rotate the part. Actually, we'll just go back to our view tab and hit isometric. Now we're ready to simulate. So we'll go ahead and click the simulate tab and then hit simulate. And then instead of just thermal analysis, we'll do thermal and structural. We'll hit the OK button. All right, so we have some results. Now, right here, they have results of thermal case. Actually, let's close this first. Now, results of thermal case. So this is our thermal distribution plot. And you can save it by going up to the arrow and printing. And then just hit preview and then print. And I'll just put it to my downloads. And I'll give it a name, Duo Test. And then you have a PDF version of it, which is great. Then you can also do an animation. So go to the play animation button and go to this gear icon and click the save. And we'll do, we'll give it a file name and a location. So let's go again to the downloads, hit Duo Test, and click save. Save again. Now that will save as an AVI file, but there are cloud-based converters. So if you just Google search convert AVI to MP4, there's stuff on the internet that will do that, no problem. But that was for the thermal analysis case. And if you want to get some if you want to make some Excel spreadsheets of it, just click the part. Let's first pause the animation and then go all the way to the end and then exit. So we will click the part and you can export field data. So this will be an Excel spreadsheet or a CSV file with nodal temperatures for each node. Click the OK button, and there it is. You have a CSV file. File, save as. Go to this PC. All right, I won't save it. And this is a thermal case. We can also go to the structural, and instead of, you can get the stress. So we can save this plot and the displacement. You can save that plot, just click and export field data. And you can show minimum, maximum values. Global min. Okay. So that's about it. And if you want to save this, right click up here, go to properties and change this, change the name and click OK, and then go ahead and save it. And that will go to your cloud 3D experience, user account. All right.